Hi everyone, so we are back at it again with the 1 month prep kit in Hackerrank. So now we are going to do diagonal difference. I have read the question likely. I just skimmed through. I didn't really read it in detail. Let's see. So we'll do the same thing. I will attempt it in front of you guys, and I will go through my thought process as I'm reading it as well. So given a square matrix, calculate the absolute difference between the sum of its diagonals. For example, the square matrix. So we know for a fact it's a square matrix. Okay, Qn. For example, the square matrix here are shown below 1, 2, 3, 1, 5, 6, 9, 8, 9. So they're summing 159 and 953 this way and this way. So the difference between these two is 2, and they're using the absolute in this case. Okay, so we need to find a way to algorithmically find the diagonal of this way and this way. So I'm guessing it's going to be something like a for loop that we can run. And just to take note of something, we need to do this as efficiently as possible, because they didn't limit us to 3 by 3. They said it could be hundreds. It could, yeah, if I'm not wrong. Is it always 3? Can it be more than 3? The first one contains a single integer n, the number of rows and columns in the square matrix. Okay, so the first line indicates n indicates the number, how big it can be. So they didn't limit us by saying it's only 3 by 3, because if it's 3 by 3, it'll be quite easy. We can just reference the specific indexes and get the value. But nope, they didn't do that. But one clue that they did give is that it's a square matrix. So I know right now it might not make a lot of sense as I'm speaking, but eventually it will make sense, hopefully. So a square matrix is useful to us because we can repeat a lot of these numbers. So if I want to reference the first one, let's just try to do it. Let's just try to brute force it first. So we have 0, 0 on the right side and 0, 1. Sorry, 0, 0, 1, 2. So 0 and 2. This one would be 1, 1, 1, 1. And this, on the right side, this would be 2, 2. While on this side, it will be 2, 0. So if by now the pattern is not obvious to you yet, what you can see now is that these values on the right side will always be the same. If I put I over here, it'll be I, because we're going in this form, in this direction. But for this, it's kind of an inverse logic. If I were to reverse this, like from 0 2 and 1 1 and 2 0, if I were to do it represented in a different manner, like 0 1 2 follows the sequential order, but this follows the reverse order. How about if I do it this way? 0 minus 1 is effectively 2, 1 minus 2, 2 minus 3. It's also like there's a kind of sequence that we can follow with this, and that way we don't have a lot of complications now. So I think I've been rambling on a bit. I'll just get straight to coding it out. So let's just print out the output first, just to see what is the format that the value is in. Print ARR. So yes, wrong answer. Okay, so this is a row, and our final array is a row array inside a column array list. Not really column array. It is packed in terms of rows. It's stacked in the order of a row. First row, second row, third row, first row, second row, third row. Okay, so let's go up now. So what I'm going to do is, I don't want to run through this thing many times. I just want it to go once. So for I in range ARR, sorry, length ARR. A benefit of knowing that's a square matrix is that if I know there's 3 here, I know there will be 3 here. So len ARR will actually give me 3, because there's only 3 items in the main thing. In the main list, there's only 3 sub lists. So I can just do this for I in range length ARR. If it is more than 3, it's no issue to me, because I know that we can just keep looping through. Like a for loop will account for all the items inside the list anyway. So for I in range length ARR, I need to create 2 counts. I need to keep count of 2 values, the right side and the left side, as they did over here. So for I in range length ARR, what I'm going to do is right plus equals ARR. For the right side, it's quite straightforward. It's whatever number next to whatever number that you have. So it'll be I and I. Sorry, I reference I. So it will reference, if you're referencing this value, it'll be 0 and 0, because you're getting the first row and the first item, second row and second item, third row and third item. So this is quite straightforward. Meanwhile, for the left side, it's not so straightforward. But basically what happens is, for second row, we are going this way. We start from the first row and we keep going down. So the row index is still I, but the column index is going to be -1 minus I. So this will make it such that the first one will be -1, because I'm doing 0 minus 1. The second one will be 1 and 1 minus 1 minus 1, which is -2. So 1 and -2. That way we should have successfully received this. We should have a summation of left and right. And what we need to do is we just put an absolute term around it. So an absolute term will bring it to the absolute form of things, which means no minus plus. So yeah, we just need to do this now, right minus left, and we're done. If I'm not wrong, this answer should give us the final value. So let's see if I get it, and let's run it. Yep. This will be the most efficient test case because we're only running it once. That means by order of efficiency, this is running at O n speed. Yeah, it's running at O n speed. O(n) time complexity. So that's the best case that we can hope for, because we have to check through all the values anyways. So yeah, this is a pretty cool puzzle, and I hope you guys enjoyed it as much as I did. And I'll see you guys in the next video. Please let me know what other questions I should try in the comments below, and I look forward to seeing your comments. See you. Bye.